2006 as one of Glasgow's original mobile massage therapists. Deliver high-quality treatments with the ambition to forge permanent relations with clientele. We specialise in on-site massage, a type of treatment that has been specifically designed to complement the convenience and availability of massage at work. It is performed with the use of a specialist mobile chair, without the use of oils or the need to remove clothing. At Massage & Glow, we believe that massage should be a part of your everyday lifestyle. Regular massage not only relieves stress and tension, but also stimulates blood circulation, can help with pain management, and promotes good mental health. A must for your busy schedule. Various holistic therapies available. Contact us now on 07530 905 152 for your mobile massage therapist.
Need security? Call Alpha One Plus Limited, a strategic security resourcing platform that connects you with licensed security personnel. We cater for our clients' security needs, from manned guarding, door supervision, event security, all the way up to close personal protection. Alpha One Plus Limited, your one-stop security solution. Call now at 44-074 2526 7909 or send us an email on info@alphaoneplus.com.
Across the World Wide Web, on your mobile devices, on social media platforms. This is Jambo Radio! www.jamboradio.co.uk. We are multilingual. We are conversational in the languages you best understand. We are Jambo Radio! Jambo Radio, inspiring.
Well, hello, and welcome to the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. Of course, you know, Glasgow is a very sunny city, and, well, of course, that's a joke. It's sunny in Glasgow, but sometimes it's maybe a little bit more grey and wet. Today is an example of such a day. Anyway, I'm your host, Dr. Adetunmise Dada, and this is the Science Show. And of course, as we know, the show is all about STEM. That is science, engineering, technology, and mathematics. And today, we're going to be tackling a very interesting topic. I don't think we've actually had a deep dive into chemistry before on this show. So that's going to be very interesting. Our goal is to inform, to entertain, and we're going to be addressing some burning issues in science, technology, engineering, and mathematics, developments from Scotland and beyond. Our interviews, you'll find, will probe some profound debates and delve into details in a way that we can all understand, of course. So let's look forward to what we have in store today. Well, today, as usual, we'll be starting with our science news highlights, and then we'll have a deep dive discussion with an expert in organic chemistry. Of course, we'll see who that is in a moment. And we're also about fun on this show. So look forward to some very, very interesting jokes. I think these may just be the funniest jokes I've ever had on the show. So I can't wait to share them with you. And of course, perhaps our guests will have some jokes to share with us as well. So we have that to look forward to. So don't touch that dial. All right. Great. So before we get into our science news highlights, we're going to have a quick introduction of our guests. So today, it is my privilege to welcome to our studio Dr. Oluwarotimi Ojo. Dr. Oluwarotimi Ojo. Now, Dr. Oluwarotimi Ojo is what you call a beacon when it comes to organic chemistry's role in medicine. Well, welcome, Dr. Ojo.
Thanks very much for having me.
Yes, it's the pleasure is all ours. Just some background on Dr. Ojo. Currently, he is in the School of Chemistry at the University of Glasgow, and his expertise, of course, enriches that department, that school in the university. He was born in Nigeria, raised in Manchester, United Kingdom, and of course, his journey with chemistry began quite early on, as he'll share with us in detail later on in the show. Good. So let us get into our news highlights for today then. So our science news highlights, we have 3 or so headlines that we want to focus on today. And it's quite an interesting one, this one. Get ready to look up. Yes, you probably remember some. I think there's a movie title called Look Up. Well, this is telling you to get ready to look up. What's that about? Well, a star just about 3,000 light years away is set to go nova. And when it does, it will light up the sky in a dazzling display that's visible even to the naked eye. So that's something that we can look forward to. Now, the astronomers anticipate the star T Coronae Borealis. Sounds a bit like Aurora Borealis, doesn't it? But it's T Coronae Borealis. And this is expected to burst into a nova, becoming a temporary beacon in the night sky. Now, this event, expected to shine for up to a week, will be a must-see for stargazers alongside this year's full solar eclipse and the appearance of a rare green comet. So I think this year is something of a feast for astronomers, wouldn't you agree? So stay tuned for viewing tips and updates from NASA to witness this cosmic spectacle. How can you see it, did you ask? Well, to make sure you don't miss it, you can follow updates from NASA through their handle on X, formerly Twitter. So it's at NASA Universe, and that's the handle of the channel on X. Great. Now, next, our next headline: City life could be reshaping our guts. Well, not in the way that you may think. It's not that it physically changes the shape of our gut, as it were, but this is just urban diets having an impact and maybe leading us to lose plant digesting bacteria. Now, this new research study published in the journal Science reveals that while our digestive systems have cellulose processing bacteria, so we do have some of those as well, this is similar to what you have, for example, in ruminant animals. These crucial microbes, once abundant in our ancestors, are now rare in modern industrialized populations. And this reduction is being linked to the diet, the kind of modern diet that we have in our cuisine today. So this change is something that might affect our overall metabolic health. And that's the key point here. It suggests a boost in dietary fiber or probiotics to help reintroduce these vital microbes. So that's an interesting one, isn't it? It's just another example of how science impacts our everyday life. Okay, now let's change the gear a little bit into electronics. So researchers at the University of Massachusetts Amherst have demonstrated that analog computing using a device called a memristor. You remember from our last live show, we talked about resistors that are able to also, or transistors that are also able to store information. So this is something not too distant from that. So devices called memristors can solve complex equations more efficiently than digital computing, which is quite interesting, isn't it? Because there was the analog computing era, and then it's now digital. But now we're saying, hang on a second, it seems you can have a situation where analog computing is outperforming digital computing once again. Anyway, the memristor, which merges memory and resistance, allows for in-memory computing that sidesteps the data transfer bottlenecks faced in digital systems. And this leads or promises to lead to significant energy savings and speed enhancements. Now, this breakthrough is something that could potentially revolutionize scientific computing tasks, from material modeling to climate science and so on and so forth. So this is quite an interesting one, isn't it? So there's quantum computing. Now there's this development in digital computing. I wonder what happens when you merge both. That could be exciting indeed. So this is something you can read about from the website of the University of Massachusetts Amherst, and this research has also been published in the journal Science. So you can read about it, all about it there. And that wraps up our news highlights, science news highlights for this week. And in fact, as we can see, these developments not only showcase the brilliance of modern science, but also where technology seamlessly integrates more and more into the fabric of our everyday lives. So let's stay curious, innovative, and of course stay tuned to the Science Show with Dr. Dada on Jambo Radio Scotland for more exciting discoveries. And let's press on now with our show through our interview. So now we're going to focus on our guest. So our guest today is Dr. Ojo, Dr. Oluwarotimi Ojo. Does anyone call you Oluwarotimi?
No, actually.
Except me.
Except you. And yeah, most people just tend to stick to just the surname, which is about a little word. Ojo.
Yes, it's a little bit easier to pronounce as well.
However, Spanish people call you Ojo.
Oh, I see. That's true, isn't it?
So,
because the J sounds different in Spanish.
Yeah, so every time I visit Spain, they always, when they see my name, they say Ojo.
And you're like, what? Sorry, who? What? Yeah, that's interesting. Of course, Ojo is a Yoruba name, isn't it?
It is a Yoruba. It's very particular to just from Ondo State.
I see.
That's where my parents from, Ondo State. And I was born in Akure before we moved to Ibadan.
Wow, nice, very nice. Yeah. It reminds me of my surname is short as well, Dada. So it's 4 letters.
4 letters. Yeah.
A little bit less.
Make it a lot easier for pronunciation.
Yes, good. Now let's carry on that track of your background. So could you give us a glimpse into your childhood and maybe focusing on some of the experiences that maybe interesting chemistry?
Yeah, I mean that's one of the things that would quite excite me to come on radio to talk about, because even students ask me the same question as to how do you know when you want to be a chemist, or when do I know I want to be an academic? And it always ties back to my childhood, as you. So I'm quite very intrigued by that question, which is quite very good. So as I said, I was born in Akure in Ondo State in Nigeria. I won't say the year, but I can easily find out. But so growing up, as you know, not to a Elon Musk family or Jeff Bezos family, and so what I mean by that is that when you get sick, there's a common disease that's specific to that Sahara area of Africa, that western part of Africa, because of the rainforest. And the disease that I'm referring to is malaria, caused by Plasmodium falciparum. So it's very common to, as I said, that western area of Africa, and also in Bangladesh, in Southeast Asia. So when I get sick, or my brothers get sick, so we don't have much money to kind of buy Western drugs such as chloroquine or artemisinin. So we had to revert back to herbal medicine. So I'm sure you probably know this medicine, we call it agbo.
Yes.
So that's the one that we always cut the bark of the tree and then soak it into water and leave it for a day or two. And after contracting malaria, so you know that you have malaria due to high body temperature. So that agbo, when you get sick, you have to give it to you. It's usually drink about, let's say, about 200 ml. You have to drink. Yeah. And it's very bitter, but when you drink it, you get well within a day or two. And what's so interesting, which I'll come back to later on, what's so interesting about this herbal medicine is that there's no side effect, and you get healed for a day or two. And because it's very bitter, I've always asked myself that what is this my parents is given to me, and I always ask them what is inside that thing, but they weren't able to tell me. Yeah. And there was a time that a company came to Africa, and specifically Nigeria, because my mom was a nurse. They had a calendar with a scientist for each month on the calendar.
I see.
So my month of birth is May, and there was a scientist called Sir Frederick Gowan Hopkins on this picture on the month of May. And as a kid, I saw that picture. I said, I want to be like him. And his area of expertise was this guy that worked on vitamin C from natural products. So since that herbal medicine is a natural product, I've always asked myself, I need to find out what's inside that agbo, if you like.
Yeah.
So most researchers worked on the seed, but not on the bark.
Yeah.
So it's the bark that, and I hope to travel to Nigeria this summer to get some of it, so that I can work on the isolation of the content of the bark of. It's called Azadirachta indica.
I see. I won't even try to.
It's a little bit
repeat
mouth. But most Nigerians knows that's agbo.
Yes.
Yeah. So
yes.
that's how that's what intrigued me or and motivated me to be a scientist, and specifically an organic chemist.
That's really, really interesting. Thanks for sharing that with us.
No
It's quite a remarkable thing, isn't it? I think my childhood as well, I had my fair share of agbo growing up.
Yeah, you ask any Nigerian, they've had a taste of it, they can tell it's very bitter.
Yeah.
But nobody knows what's inside of it. There's a chemical substance
that's responsible for the effectiveness of it.
And as I said, when you take normal synthetic drugs, you do get side effect. But with this herbal medicine, there's no side effect.
I see.
But when it comes to the way drugs are approved in a Western country like FDA, Food, Drugs and Administration in the United States, and NICE here in the UK, they need to know the structure of the compound, before they can approve it.
Yeah.
But if you're dealing with a herbal medicine, you're dealing with like a soup with a lot of things inside of it. So until somebody worked on trying to figure out the active ingredient inside of it, they will not approve it. So that's why least herbal medicine being approved by the drug regulators in the US, in the UK, or in Europe.
That's really interesting. Yeah. That's really interesting indeed. Now, let's maybe reflect a little bit on your school days.
Sure. So,
did you have some of your education in Nigeria?
Yes, so I had my nursery, my primary, and the secondary. So you had the GSS, and then you do the SS. So I did my GCSE in Nigeria. So I finished around 2001, 2002.
Nice.
And then I came, my mom relocated to the UK to work as a nurse in NHS. So she decided to bring us, our family, of course, to the UK because she was feeling lonely and that kind of stuff. I kind of remember what she said to me because she had to invite us, my dad and my siblings, just gradually. So I just remember this. I think I just finished my GCSE and I was trying to get into LAUTECH and LAUTECH of Commercial in Ibadan or in Oyo State. And one day she just rang and she said she heard that I like reading a lot. UK is very good for people that like to read. So I'm going to bring you over to the UK. So I came to the UK and started my college at the Manchester College, they call it now. In Manchester, so I started my AS level, then did my A2 level, and after I finished, I did both 2 years in further maths, chemistry, and biology.
I see.
So then I started my undergraduate degree in Newcastle University in 2005.
Nice, very nice. And then from there, did you do an MSc? Did you do a master's?
So that course in Newcastle University is a 4-year degree course with master's embedded in it. So it's called chemistry with medicinal chemistry plus 1 year industrial placement at Glasgow. So as part of my 3rd year, I did distance learning. And at the same time work for the company from 9 to 5.
That's nice.
It's part of my industrial placement. So I'll go to work to work for the company from 9 to 5. Then from 6 o'clock to 9, I have to basically read. They send me notes or lecture notes from Newcastle University to read and then do some test.
Wow.
So I read the notes from 6 to 9, then do the test, then send it back to Newcastle at 10 p.m. So it was
that's a full schedule.
It was tough, but it made me know how to work harder, and then so I learned how to juggle both.
I see.
So work for the company 9 to 5, then 6 to 10 do university course.
I see.
Yeah.
So the entire program up to your MSc.
Yeah, it was 4 years.
Was it MChem?
It's MChem.
MChem,
yeah,
yes.
Masters of Chemistry. So it's
the
like a
entire
4
thing.
Yes,
Wow.
yeah, the entire thing is because normally people do BSc 3 years and then they go and do MSc.
Yes.
But mine was just integrated.
That's nice.
With industrial placement as third year.
That's really cool.
It was pretty hardcore, but
Yeah.
that's where I like it.
And after that, you moved into your PhD.
Yes, so it was when I was doing my industrial placement that I realized that if I really want to achieve that goal of figuring out what's inside of our goal, I need a PhD, because a lot of people just don't really understand why they do PhD or what's it for. So
Yes.
for me, I realized that I need a PhD degree to build an expertise.
Yeah.
Okay, in knowing how to make compounds,
Exactly.
or isolating compounds from natural products. So
Yeah.
that's the whole essence of why I needed to do a PhD, and that's the reason why I pursued the PhD degree starting from September 2009 at the University of Liverpool, and then
Yeah.
finishing around April, May 2014.
I see.
So that was. I went to do was when I was in industrial placement. I realized that in order to fulfill that research goal and that
Yeah.
research ambition, I needed a PhD degree. Not because I loved the title, but
Yeah.
because I needed to be trained
To
and
that
developed.
level.
Yes.
Yes. Yeah. There's nothing like having a dream, is there? Once you have a goal,
Yeah.
it drives you.
Absolutely.
And you can put in the work.
So
Yeah.
and it happened to me right from the young age, and I
Yeah.
just put my heart and soul into it, and I just pursue it with everything that I got. Basically.
Interesting. Fantastic. Thanks for sharing that with
My
us.
pleasure.
I think it's time now for a music break. And we'll be listening to a track by Inusa Dawuda. It's entitled Love is in the Air. And we'll be right back. Well, welcome back to the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. And we'd like to take this opportunity to shout out to our sponsor, IOP Scotland, Institute of Physics Scotland. And it's a nice time as well to remind you that you can listen to us on DAB, and you can also listen and watch us live at jamboradio.co.uk. Also, don't forget that you can catch up with past episodes uploaded to our YouTube channel, Jambo Radio Scotland. So that brings us back to our interview and our interesting and insightful discussion with our guest, Dr. Oluwarotimi Ojo. Now, Dr. Ojo,
Yeah.
would we be able to dive a little bit deeper into your expertise now? So
Okay.
now let's get into organic chemistry.
Sure.
Now, could you describe for our listeners perhaps some of the cutting edge tools and techniques that you use in your research?
So in terms of organic chemistry, it's one of those part of chemistry that's exciting but less well understood, and also even students sometimes they find it a bit difficult to execute it. So it's the part of chemistry whereby you have to make something. This is where you even in so let's say like the ticket that's currently used on ScotRail, they've switched to polymer. The polymer inside of it is chemists that made it. Okay, so organic chemistry is that part of chemistry whereby, as I said, you make, it's where you make things. And when I say it's like, the best way to describe it is like, we always, for me anyway, I always refer myself to an architecture and a builder. So what I mean by that is I look at the molecule. Most importantly, let's say I want to treat a disease. You need to make a molecule. So you first of all design the molecule, just as you would design a house, and then you go into the lab to make that compound. And you do so by building, by adding building blocks together, using some established protocol or whatever, maybe a protocol that I have designed myself.
Yeah.
Okay? So what I mean by that is, chemistry, organic chemistry is like, when it comes to building that, making a molecule, using precursors, chemical precursors, we call them, but to make it understandable, it's like they're like see them as a building block. Okay, when you build a house, when you're building a house, you notice that they use cement to hold the blocks together. For us, that cement is like a reactivity between the two building blocks. And so we call one that is a nucleophile and one that is electrophile. So the best way to explain that is a lock and key. So one is giving and the other one is receiving. So that's a technique that we use to build a molecule, and we keep adding to that molecule until it becomes bigger and bigger and bigger, until we reach our end point and say, okay, this is the molecule that we design. It doesn't always go straightforward. It doesn't happen. But for me, and a lot of people do struggle, that they said that you could draw whatever molecule you want on a paper. It's about making it. But I pride myself on that, on my ability that whatever I draw on paper, I'll do whatever it takes to make it.
I see.
So, but you do that, as you said, by using different techniques. So some precursors just won't react together for whatever reason. So you have to kind of modify your technique. So the type of reactivity. So we are called them reacting partners. That needs to come together to join. So the best way to describe it is like a cement that holds the two bricks together.
I see.
So we have bricks as well that we want to bring together to make
build
to build it. So being an organic chemist is like being an architecture and being a builder. You must be able to design and you must be able to make it.
I see.
So
very nice.
A lot of people love the designing part. But it is the making part that makes it difficult, because you now need your expertise to go into the lab to execute your plans and to modulate or modify the reaction conditions that you need to do to merge the two building blocks together to get what you want. And so organic chemistry it has multiple layers, and those two layers is designing and then building it.
I see. Okay. It reminds one a little bit about of cooking as well.
Correct. Yeah.
So it's like a recipe almost.
Yes. So I enjoy cooking. So I always say something to my student that I cook at home. That's what I eat. But I cook in the lab as well. But I don't eat that one. Okay. So that's a joke for you. So whatever. Good. So it's like a recipe, and the order of addition is very critical in organic chemistry. So with cooking, you can add. Well, in some cases, you could just have everything together, and you still get your meal. Okay. Yeah. But in organic chemistry, the order of addition is very important. Okay. So you cannot just. So for example, if there's something that we call pronucleophile. So let's say, for example, that and that reactive partner is not. It won't do anything on its own. Yes. You have to kind of make it reactive inside the round bottom flask first. So our cooking pot is called round bottom flask. Okay, that's where we put all the chemicals in, and you react. And you
use heat as well.
Yeah. So and we use organic solvent as our water or cooking oil, if you like. And then in some reaction it requires heat. Some reaction don't need heat, so that's room temperature. And some reactions you have to cool them down, because the reacting partner you're using is too reactive. So you cool them down to kind of so that kind of reaction we call them exothermic. Yes. So basically they can run. They basically call it thermal runaway. Basically, they just give off a lot of gas, and so you have to kind of cool them, do them at like -20 or -78. That kind of reaction. Nice. So there's some compounds or some nucleophile that you have to kind of make them inside the round bottom flags. Okay, this is where you use another compound to activate it, if you like, before you had the other partner. Okay, so let's say you make the lock inside the cooking pot, and then you had the key into the lock that you've already got inside that pot.
I see.
And so that's how we. So the order of addition is very important. So you cannot just add lock and key together inside the round, but inside that cooking pot. In some reactions requires you to kind of to wait a bit before adding the other partner to it. So yeah, there's and that's very important for whether the reaction works or not. Although there is some reaction whereby you can just add everything together and the reaction will work anyway. Reaction, they're very robust, or they just general. So we call them. I always say that there's nothing you can do to screw up that reaction. Okay, those are the type of reaction that first year undergraduates can do, that we love to do.
I see.
Because they know they have less experience in doing that. So if you give those type of reaction that you could just add everything together, they're unlikely to screw it up, to mess it up. Because but some reaction that are much more sensitive to the timing, technique, and the timing, everything, temperatures. So we give that type of reaction to, let's say, somebody that's doing a master's degree or somebody that's in the first year of PhD.
I see. Yeah. So one question perhaps that's good to clarify. Thank you very much, Mr. Producer. That's deserving of an applause indeed.
Thank you.
One question I wanted to ask that I think would be nice to clarify for our listeners is, what makes organic chemistry different? So how is it different from just chemistry, doing reactions? And
so chemistry itself is divided into different disciplines. So we have organic chemistry, we have inorganic chemistry, we have physical chemistry, and there's radiochemistry as well. So these are the people that deal with the nuclear stuff.
There's quantum chemistry.
The quantum chemistry as well. As I said, what makes organic chemistry different is because you have to make stuff.
Really?
Okay. Yes. Okay. So inorganic chemistry, they make stuff, but they mostly use transition metals. Okay. To do that. So organic chemistry just organic compounds. Okay. All right. So we are the one that makes your ibuprofen, your paracetamol, your aspirin. So it is organic chemistry that makes those compounds. Okay. And that's what makes organic chemistry super different from other discipline in chemistry. So, and most students want, when they in the department school, they always want to do organic chemistry. So we're kind of very proud, we take so much pride in that we give students a very exciting challenge, because they find organic chemistry challenging, and it's more easy. It basically prunes their curiosity. Okay, so organic chemistry is about making stuff, and making difficult stuff. So that's what makes it different to other discipline of chemistry.
Very good. Thanks very much for that. I think we're going to take another music break, and when we come back, we're going to talk a little bit more about your research and your research vision, and we're going to delve again as well into the question of the week. So for our music break, we'll listen to this track entitled Pangolo, and we'll be right back.
Oh na 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 na, oh la, my baby tomato, you captured my you hit me like arrow, and you reach me for marrow, no, it to say nothing dey my colo. I was driving around Bangolo. Would you still chop my dodo? Or would you say goodbye? Cause for this whole wide world, Ivana oh nana, then you blow my mind. Nobody is closer. Now you they float my boat, oh. From coast to coast, you give me hope, oh. Girl, you know, now you be my woman. Only you, I know fit for another one. And only know until this life is over. My darling Sunita, I wrote you a letter. Say you go love me forever, or you go off like Nepa, no. To say nothing dey my colo. If I was driving around Bangolo, would you see the chop my dodo? Would you stick with me like it do me? The say nothing dey my colo. Driving around Pangolo. Would you see the chop my dodo? Or would you say bye bye? Cause for this whole Mana oh nana, you blow my mind. Your body is closer, but your love be like arrow. Can you reach me for marrow? Baby, love me tomorrow, baby. No, no. Girl, you know, now you be my woman. Only know, I know won't start all over now. Only you, until this life is over.
On your mobile phone and on all social media platforms. Jambo Radio.
Welcome back. This is the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. And once again, we'd like to shout out to the team here at Jambo Radio, the production team. Otuekong Umoren is our producer, and of course, many others working behind the scenes to make this exploration of science possible. And also would like to thank our sponsors. So IOP Scotland, we would like to thank the University of Glasgow for giving us the opportunity to do the exciting research that we can bring to you, and also of course the EPSRC for supporting us as well. So now we've come back to our discussion. Focus on, once again, going back to our guest, Dr. Ojo, Dr. Oluwarotimi Ojo. We're going to focus on his research and his research vision. So, Dr. Ojo, this is something that I'm sure you've had to do so many times.
Yep.
So, would you like to break it down for us?
Okay.
So, your research vision in a way that we can understand. You know, those of us who are non-specialists in organic chemistry.
Yeah. So to kind of break it down in a layman terms, so in order to make new medicine, you need to. So let's say, for example, when COVID happened, and we were scrambling for a cure. One of the critical problem we faced during those COVID time was that when the vaccine was found or developed, it took a while to develop it, and also it took a while to scale it up. So let's take this for another disease, let's say HIV, diabetes, or cancer. So when we find a compound, so we've designed a compound, we've make it, okay. The number of steps to make is very important.
Yes.
Okay. Because it will be that number of steps will determine how cheap it is and how quickly we can make it.
True.
All right. So my research vision and my research activity is focused on finding to make key compounds that are currently expensive, trying to find a way to make it quickly, okay, and to develop a way to make it cheaper.
Yeah.
All right. So a good example of that is called baclofen, that is used to treat muscle spasm. Okay. So current steps to make it is about 10 to 11 steps. So I'm trying to use my chemistry that I've developed in the lab to be able to make it in just 4 steps.
Wow.
So that's my current research activity. Okay.
I see.
And then long-term research vision is to be able to kind of to just develop a chemical reaction that can help us to make drug molecules very quickly in shorter synthetic steps.
Yes.
Okay. And now we make it because, for example, some drugs that is used to treat cancer, they're very expensive. And the reason for that is because it took 10 years to develop them, and it took a long, like let's say 10 or 20 synthetic steps to make them.
I see.
So that's always the way. So if you hear that a drug is very expensive, it's because of that reason. That
the bottleneck.
Yes. So it is that bottleneck, the organic chemistry, which is designing and making that compound, is the bottleneck of most drug discovery
I
for
see.
the development of new medicine.
That's interesting.
Okay, so that's the space that I occupy as an organic. I want to occupy as an organic chemist.
Fantastic. Thanks very much for that. I think that's really, really well put together, well expressed. I look when research vision is something that when you hear it, there's no way you won't see how that affects you in some way.
Yeah.
That's the most powerful one. I think you've got a really good one there.
Thank you.
Fantastic.
Okay.
So before we get into the question of the week, which is how does organic chemistry innovate medicine? We've already heard some hints at the answer to that question, but before we get into that, what makes you different from a chemist, from a pharmacist rather?
Yes, so I love answering this question because pharmacists are just the people that. So when I make a compound, okay, I know I've made it. I give it to pharmacologist, or biologist to test it. Okay, on either on a protein that we call it in vitro, or to test it in a mouse. In vivo, so animal testing, whatever your opinion is on that, and then it goes to human clinical trials. So phase 1 is just to test the toxicity. Phase 2 is to test the potency and toxicity on a small scale, and phase 3 is to test the toxicity and potency on a large scale, on a large cohort. So what I just explained is just organic chemists were at the beginning, the bottleneck, then the pharmacologist and the molecular biologist, they're the one that do all this testing. In between, we would test the dosage. So the amount that somebody need to take at a particular time before they can take. So you've heard of your doctor telling you only take 2 pills a day or a week. So it is the pharmacist, they regulate that part.
I see.
Okay, how much of a drug. So they tell the doctors that do not administer more than 2 pills per day for this patient.
I see.
Okay, so that's where pharmacist comes into it. They tell you in terms of dosage, but that get found out during the clinical trials, either in animal testing or in human testing.
I see. Interesting.
Okay, so when you go to your pharmacist, they just say this is drug that you want, but this is how much you should take per particular day, how much you could take per day or per week.
I see.
So that's so it's like a long line of many sciences, but always start with the chemist making the drug, then give it to biologist and pharmacologist, then it gets to the pharmacist, then the doctors listen to what the pharmacist says. So
interesting. That's very, very insightful. Thanks very much for sharing that with us. So how does organic chemistry innovate medicine?
In many ways. So let's take bacterial infections or like malaria or so there's something that we call antimicrobial resistance.
Yes.
So what tends to happen is that when you take a particular drug to take a disease, or it happens in cancer too. So when we make a drug to treat a particular disease, cancer or microbial infection or HIV, what tends to happen is that the protein that drug mutates. Okay, and when they mutate, they either build resistance, which means the current drug to treat it doesn't work anymore.
I see.
Okay, so the current one to explain that better is called antimicrobial resistance.
Yes.
So that means that the current drug, that chloroquine, that was used to treat it back in the, because human beings, we evolve as we grow. Okay, so that might leads to evolution or mutation of that particular protein that previous drugs targets. Okay, so in that case, after that resistance, then they say like, okay, we need to come up with a new drug. We need to innovate the medicine. So they come back to the person right at the beginning, organic chemist. So they say that, okay, so we as an organic chemist, they will ask me that what part of the structure will I change to innovate, to come up with a new drug. So I will look into the mode of action, and I'll look at how the the protein target that causes this disease as mutated, then again I design a new drug and then make that new one.
And
so
do you do that in collaboration with pharmacologists?
Yes, so you do that in conjunction, in collaboration, in discussion with biologists, because they have in detail idea of how that drug is interacting with the protein or with the cell. Okay, so they will tell you that, your drug is doing this, your drug is doing that. So as a chemist, organic chemist, you know that, okay, because there's something that we call functional group. So we have an idea of how these functional groups interact with different things in the body. So from there, I could say that, I need to take that functional group out. I need to put this functional group in, and overall, you design a new drug. You innovate a new drug, and then you go into the lab and make it as an organic chemist. And then the process cycle. And then the process cycle starts again. Okay, so thank you. So that's how organic chemistry innovates medicine. Okay, so they will say, this drug is not working. So you start from the patient. The patient will start saying that you asked me to take this drug, but this drug is not working anymore for me. And so when the doctors start receiving such complaints, it start to build. They start having about 100 patients saying the same thing, that the drug's not working anymore. So they then pass the message right all the way down to organic chemists that you need to come up with a new one. Because that's a resistant against the one that you developed before.
Good, fantastic. Thanks very much for sharing that with us. There's so much we could say, but time is not gonna let us do all or say all that we would like to say.
We could do a quick fire answer.
yes. So, of course, as you mentioned earlier as well, your research is looking at how organic compounds extracted from natural sources like the bark of trees in agbo, how they transform into these kind of viable medical treatments. So that's something to look forward to over the coming months and years.
Absolutely.
Perhaps. So now this brings us to another music break, and we're going to listen to a song entitled Kilele. We'll be right back.
Kana musica, coming down with this something. Baby, talk to me, help me check this thing. I need you desperately, I want you endlessly. Your eyes keep calling me, I feel you constantly. See how you blew me away. I feel in my soul and my heart on a daily. Cricketa, which kind of bonga feeling be this shit? Kilele, 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 kilele. What is this? Kilele, 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 kilele. Which kind of bonga feeling be this shit? You are the winner, and this is getting stronger. So hold me closer, let's make it over. Love you forever, no matter the weather. See how you blew me away. I feel in my heart and my soul on a daily. Rickety, clickata, which kind of bonga feelings be this shit? Kilele, 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 kilele. What is this? Kilele, 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 kilele. Which kind of bonga feeling? Remix. Me happy, feel better, feel yakata. Spot tag bada, me happy, full ground scatter. Me I go, Afijo, a new dancer. Come me say, come me down with this something, and there's something in the sweet me, and it is feeling like a movie, and I never been so groovy, groovy, groovy. Kilele, 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 kilele. What is this? Kilele, 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 kilele.
On your mobile phone and on all social media platforms, Jambo Radio.
Yes, hello, and this is the Science Show on Jambo Radio Scotland, broadcasting from Glasgow. We've been having a very insightful discussion with our guest, Dr. Oluwarotimi Ojo from the University of Glasgow. And it's been a very, very, very good one, a very enjoyable discussion indeed. Perhaps before we round up today, would you like to just tell us who funds your research and maybe give a little shout out to them?
Yeah, the School of Chemistry, they've been very generous, and the School of Chemistry Management Group, they're very supportive of early career researchers, lecturers. So, they've been basically just giving me enough money to allow me to basically explore all this research vision, at least to make a start, and that's the important thing. So, so they've been very, very, very supportive of my career so far. I mean, being my first academic post as well, I kind of appreciate them for at least giving me that opportunity to be able to be an academic. Since they've appointed me, they've been very supportive of my research and my research vision, at least to make a start. And so the hope in long term or moving forward, the idea is then to of course apply to APSRC for much more bigger grants that will allow me to kind of tackle difficult topics in organic chemistry.
Fantastic. So shout out to the School of Chemistry at the University of Glasgow. Great. So let's conclude then with the promised much anticipated science jokes that are themed around organic chemistry. So there's one here that I'd like to share. Tell us maybe if it's funny or not. Okay.
Sure.
So it says, the first one says, why do chemists like nitrates so much?
I can convert it to another functional group that's called amines.
Okay, good.
Okay.
That's the ethical answer, right?
But nitrates, some people that the military likes it because it's very reactive.
I see.
Okay.
That's another ethical answer. So let's get one here.
Okay.
It says, because they're cheaper than day rates.
Okay. They're very cheap, that's true.
Yes. Okay, what about this? What do you do with a sick chemist?
Oh, nothing, because they're not useful to me.
Good. Nice try.
They cannot be in the lab.
Yeah. So, good. That's again a serious answer. That's correct. But here's a more unserious one.
Okay.
You can't heal them.
Oh, okay.
You can't cure them.
No, you cannot.
Then you might as well bury them.
Ooh, okay. I still need them alive.
Do you see the play on words there? You can't heal them. Mm-hmm. So helium.
Oh, helium that's a guy.
And you can't cure them. Curium.
Curium, okay.
Then you might as well barium.
Okay, barium. Okay.
See,
these are nice. So helium is one of the inert gas that we use for cooling the probe in NMR, nuclear magnetic resonance machine. So it's very useful. It's a good one.
Yeah. So anyway, that's all time will allow us to
so much
explore today in chemistry jokes.
Yeah.
Mm-hmm. Good, and that's a wrap on this week's exploration into the fascinating world of science. Of course, whether you're an avid enthusiast in science or whether you're just wanting to keep up with the latest news in the science world, well, this is the place to be. And of course, we'd like to hear from you. Feel free to share your thoughts and comments about today's show with us by email or through our website, jamboradioscotland.co.uk. And with that, we'd like to shout out to our wonderful production team and our listeners for tuning in. And this is Dr. Dada signing off. Until next time, we'll say, stay curious.